Okay, welcome to the first video going through Edexcel 8FM0-27, June 2024, question 1. So, we've got this question here, and looking at the question, we've got a list of 11 numbers being shown, and needing to be sorted into descending order. We're asked to carry out a quick sort to produce the sorted list. So when carrying out a quick sort, we need to choose pivots, and those pivots need to be the middle, or if there's no middle because of an even number of items, a middle right. So let's do this quick sort really quickly. So we've got 4, 6.5, 7, 1.3, 2, 5, 1.5, 6, 4.5, 6, and 1. So we're told we've got 11 items, so the very middle element is going to be item number 6. So in that case, the first number that we're going to use as a pivot is 5, so we're going to circle it. So when doing a quick sort, we need to arrange the numbers. We need to go left to right, and if a number is greater than the pivot, when we're sorting into descending order, we need to move it to the left-hand side of the pivot. If a number is smaller than the pivot, we need to move it to the right-hand side. So going through this list, I'm going to find all the numbers greater than 5. So the first one is 6.5, and then 7, and then 6, and then 6. Now I'm going to write my pivot 5, and I'm going to put a box around it. So the position of this pivot should not change. Now I'm going to go left to right and add all the numbers smaller than 5. So we're going to get 4, 1.3, 2, 1.5, 4.5, and 1. We now need to select some more pivots. Currently in this sublist to the left of 5, we've got 4 items. The pivot would appear in the middle here. However, that's a bit problematic because there's no number, so we're going to use the middle right element, which is going to be 6. So taking that to be our pivot, we're going to do the same thing to the list on the right. Again, there's an even number of items, so we're going to use a middle right item, which in this case is 1.5. So again, applying the quick sort, we're going to get 6.5 and 7 because both of those are larger than 6. And I'm now going to fix 6 in place. And on the right hand side of a 6, I'm going to keep this 6. So numbers that are the same size as a pivot are really awkward, but they need to stay on whichever side of a pivot that they're currently on. So in this case, the 6 needs to stay to the right of the pivot 6. And I've now put the pivot into a box, so it's now fixed into position. I'm going to keep 5 in a box. I'm going to do the same process to the sublist on the right. I'm going to put all the numbers larger than 1.5 first. So I'm going to get 4, 2, and 4.5. I'm then going to get 1.5. I'm going to go draw a box around it to fix it in position. And finally, I'm going to go left to right again. I'm going to get 1.3 and 1. I now need to select my pivots once again. So this is a sublist with 2 items in. So the second item is to the right of the middle. 6 is by itself. And when numbers are by themselves, it does get a little bit awkward. However, we can select it as a pivot and then fix it into position if you want to be really formal. So I'm going to select 6 to be a pivot. 2 is going to be a pivot as well. And finally, this 1. So I'm going to do exactly the same process. 6.5 is on the wrong side of 7, so they're going to swap around. So I'm going to get 7 and 6.5. I'm and 7 is now going to get a box around it. This 6 here stays in place with a box. The 6 stays in the same place because it's only a list of 1. It's going to get a box around it because it's now in its final position. 5 stays where it is with a box. And now we've got a list, 4, 2 and 4.5. So I'm going to go left to right and put in all the numbers greater than 2. So I'm going to get 4 and then 4.5. And now 2, and 2 gets its box because it's now in its final position. I do have to go through this sublist again and see if there's any numbers smaller than 2 to put to the right hand side of 2. But there are not, so we finish there. 1.5 stays in its box. 1.3 is larger than the pivot 1, so 1.3 will stay to the left of 1. And 1 gets a final box. And then last but not least, we've got to do pivots again. 6.5 becomes a pivot, 4.5 becomes a pivot, and 1.3 becomes a pivot. So I'm going to do this again. I'm going to get 7, which stays in place. 6.5 is its own sublist, so 6.5 gets its own box immediately. We're now going left to right until we hit another sublist. And we've got one now with sublist 4 and 4.5. So 4 is smaller than 4.5, so it's going to go to the right hand side of 4.5. .3 gets its own box, and we've completed that pass. Last but not least, 4 is the only number that's not been circled or boxed yet. We could circle 4 and do an entire another pass, but actually we can leave it after circling it because every number now has a circle or box. So we know that every number must be in its final position. So we've now sorted the numbers into descending order. So, mark-wise, you would have got the first mark for doing a quick sort, for selecting your pivots and doing the first pass. So you would have gotten a mark for getting this following row correct. You'd have got the second mark, the A1, for doing the second and third pass correct. So for sorting numbers to this part. And finally, the final mark is awarded for the completed list. Okay, use a first fit decreasing bin packing algorithm to pack the numbers into bins of size 10. So I'm going to write my list of bins out. I've got bin 1, bin 2, bin 3, bin 4, bin 5, and I'm going to do a bin 6 as well. I don't know whether I'm going to need bin 6, but I'm going to write bin 6 out. And if I need any extra bins, I can add them. And first fit decreasing bin packing algorithm, I'm going to go left to right on my sorted list. I'm going to place the item into the first available bin that it fits into, starting at 1 each time. So 7 fits into bin 1. However, 6.5 cannot fit into bin 1 because the bin only has a space of 3 remaining. So 6.5 must go into bin 2. 6 cannot go into bin 1 because that would give it a size of 13. 6 cannot go into bin 2 because that would give it a size of 12.5. So 6 is going to go into bin 3. Next up is the other 6. We've already established 6 cannot fit in 1 or 2. 6 cannot fit in bin 3 either because we'd have a size of 12. So 6 is going to be placed into bin 4. 5. 5 cannot fit into bin 1, 2, 3 or 4, so 5 must go into bin 5. Next up is 4.5. Now 4.5 cannot fit into bin 1, no bin 2, no bin 3, no bin 4, but it can fit into bin 5. So I'm going to allocate 4.5 to bin 5. 4 can't fit into bin 1, can't fit into bin 2, but it can fit into bin 3. So I'm going to place this object with size 4 into bin 3. 2 can actually fit into bin 1. So I'm going to put 2 into bin 1. 1.5 cannot fit into bin 1, there's only a size of 1 remaining in bin 1. But it can fit into bin 2. So that's where I'm going to place it. 1.3 would take the total size in bin 1 to 10.3, which isn't allowed. Bin 2, however, currently has a size 8 inside. So adding 1.3 to that would give us a total of 9.3, which is smaller than 10. So 1.3 can fit into bin 2. Last but not least, 1. And 1 can actually fit inside bin 1. Okay. So how are the marks allocated? So marks in this case, there is a method mark, an M1 mark, for getting these following numbers to the correct bin. So any number circled in orange has to be placed into the correct bin to get the first method mark. If any of those numbers are in the wrong spot, you won't get the mark. The second mark, the A1 mark, will be awarded for allocating 2, 1.5 and 4 into the correct bins. Then finally, the final A1 mark will be allocated if you put 1 and 1.3 into the correct bins. Okay, moving on to part C. Determine whether our answer to part B uses the minimum number of bins. So, part C requires us to use some theory to find a lower bound for the number of bins required. So let's try calculating it. The lower bound is going to be the sum of all of the sizes divided by the number of divided by the size of each bin. So we're going to get 4 plus 6.5 plus 7 plus 1.3 plus 2 plus 5 plus 1.5 plus 6 plus 4.5 plus 6 plus 1. And our bins have size 10. So we're going to divide this by 10. So we're going to calculate this. This is going to be 44.8 divided by 10, which is equal to 4.48. And doing this calculation will give you your first method mark. So this is going to be an M1 right here. The next thing you have to do is determine whether our answer in part B uses the minimum number of bins. And we're going to say that the minimum number of bins required is 5. That's all you have to write. And by saying that the minimum number of bins required is 5, you can now conclude that the solution is optimal. And writing that will get you your final A1 mark. Okay, last but not least, explain how we know that at least one of the first two passes of a bubble sort was not carried out correctly. So we've got a sorted list after two passes of a bubble sort. And really importantly, the bubble sort on each pass takes the smallest number, if we're sorting into descending order, and bubbles it all the way to the end. On the second pass, it'll take the second smallest number and take it all the way to the second position to last. On the third pass, it'll take the third smallest number and put it into the third position from the end. And the second smallest number is 1.6. So we expect for the second smallest number to be second to last after the second pass. We see that 1.7 is in the space that 1.6 should be, which unfortunately isn't allowed. So we know that the bubble sort has not been performed correctly. And looking at the mark scheme, an answer saying that the lowest two values should be in the two far right positions, and they are not, would get you a mark. Alternatively, saying that 1.6 is not in the correct position will get you a mark. So you just have to say that there's a particular number that's not in the correct position, and that will get you a mark. Or you can state the theoretical layout of how the sort should work. The lowest two values should be in the two far right positions, and they're not. And that will also get you a mark. So this is the end of video 1. So thank you for watching, and goodbye.